Summative review. Earth rotates on its axis once every 24 hours, 1 day. The rotational axis is tilted to 23.4 degrees, so 23.5 or 23.4 degrees. The direction of rotation is counterclockwise. Revolution. Earth revolves around the sun once every 365.25 days, which is equal to 1 year on Earth. The path is an elliptical orbit. Orbit and revolution are the same terms. Here we're going to name the seasons. In order to name your seasons, you want to focus on the hemispheres that are tilted toward or away from the sun. If the hemisphere is tilted towards the sun, it's summer. You have more direct rays of sunlight, more hours of sun, the temperatures are warmer. If the hemisphere is tilted away from the sun, you're in winter, where the sun's rays are indirect. You have shorter hours of daylight and cooler temperatures. So I'm going to minimize, and I will grab some web paint and we can draw this. Okay, so the first thing we want to do is kind of look at that axis. Here our axis is all pointed in the same direction, and I'm just going to put a northern star here and make my axes all point in the same direction. Okay, now I want to focus on my northern hemisphere. That northern hemisphere is tilted towards the sun here, so I'm in summer. Okay, I want to go counterclockwise revolution, and I want to look at this model to the left, and I'm looking at the northern hemisphere. Here, the northern hemisphere, and I'll label it NH for northern hemisphere. My northern hemisphere is tilted away from the sun. So in this position, I'm in winter. In winter, I have shorter hours of daylight and cooler temperatures. Okay, now your southern hemisphere, which is the bottom portion of the Earth, is opposite of what your northern hemisphere is. Okay, so if the northern hemisphere is summer, your southern hemisphere is winter. Over here, if my northern hemisphere is winter, my southern hemisphere is experiencing summer. These are your equinoxes, where you have equal hours of day and night, so neither axis is tilted toward or away from the sun. You have equal hours of day and night. So in order to figure out these seasons in your northern hemisphere, okay, what you need to understand is you go counterclockwise. If this is summer and this is winter, you have to understand, well, what season is in between summer and winter? So summer, fall, or autumn, so I'm just going to put fall. So summer, fall, winter, this northern hemisphere must be spring. Okay, and they kind of give us a little clue here by saying what month it was. Okay, so I know September is the fall, and I know March is spring because we're in spring break, right? Okay, so let's look at this picture and answer the question. Which position represents the location of Earth in relation to the Sun on June 21st in the Northern Hemisphere? Name the season and explain. So June, you need to understand that June is summertime. So pretty much they're asking you, which position in the Northern Hemisphere is it summer? Okay, so if we look at position A, Position A is tilted away from the sun. So the northern hemisphere here is winter. I'm going to go counterclockwise, skip my equinoxes, and go to position C. In position C, I can see that the northern hemisphere is tilted towards the sun, so I'm in summer. So this would be the answer to my question. Let me reread it. Which position represents the location of Earth in the relation to the sun on June 21st in the northern hemisphere? Name the season. So position C is showing summer in the northern hemisphere. Okay? All right, we're going to use this diagram below to complete the chart above, okay? So we have the sun, here's Earth, here's location A, location B, your imaginary axis, and your imaginary equator line. This location is experiencing, so let's look at location A. Location A is experiencing what? Is location A experiencing winter, spring, summer, or fall? So, position A is in the southern hemisphere. Here, your southern hemisphere is tilted away from the sun. So I would say position A is experiencing winter because the hemisphere is tilted away from the sun. Let's still focus on position A. Is position A day or night? Okay, position A is experiencing day because that side of the Earth is facing the sun. Location A, more or fewer hours of daylight. Position A is going to have fewer hours of daylight because it's in winter. Now let's focus on location B. Here's location B. Is it winter, spring, summer, or fall? So, your northern hemisphere is tilted towards the sun, so location B is experiencing summer because that hemisphere is tilted towards the sun. Is it day or night at position B? Position B is experiencing night because that side of the Earth is not facing the sun. Does position B have more or fewer hours of daylight? Position B has more hours of daylight because that hemisphere is tilted towards the sun. We're going to review plate boundaries. Your assessment is a summative. So let's name each plate boundary, convergent, divergent, or transform. When the boundaries move away from each other, it's a divergent boundary. When the boundaries slide past each other, it's a transform boundary. When the boundaries converge or collide, it's a convergent. They're coming together. Divergent boundary is the boundary between two tectonic plates that are moving away from each other. The crustal formation depends on the type of plates that are diverging. So let's look at a continental plate diverging. This is happening in Africa. This is a satellite image where part of Africa is diverging from the other part of Africa. How about oceanic crust? On the bottom of the ocean, if we have an oceanic crust dividing from an oceanic crust, we get a mid-ocean ridge where volcanoes form. And here is a picture on a map. This mid-Atlantic ridge runs from the top of the Atlantic all the way to the bottom, and this is underground volcanic mountains in the ocean. Convergent boundary, the boundary between two colliding tectonic plates. The crustal formation depends on the type of plates that are converging. So converging, coming together, or colliding. If we have a continental plate converging, you get, an example would be the Himalaya Mountains, where the India plate is colliding with the China plate. If you have a continental oceanic plate, converging, you would get the Andes Mountains. So you have the continental plate of South America colliding with the oceanic plate. If you have an oceanic plate converging, you can get the Aleutian Islands would be an example, forming island arcs and trenches. Whenever you have oceans involved, you're always going to have trenches. Transform boundary is between two tectonic plates that slide past each other. The results are going to be faults and earthquakes. Earthquakes are more of a process, a happening, and earthquakes are actually found at all boundary types. It's just that transform boundaries are most active. So your direction of your plates are sliding past each other, and again, an example would be the San Andreas Fault in California. Your assessment is also on topography. So a question here, looking at this topographic map, which side of the mountain is more steep, the west or east side? Explain. So remember, a contour line is going to be a line that has the same elevation all the way around. And this is a topographic map of a hill or a mountain. And it's down here, it's telling you your contour intervals are going by 20s. So if this is contour 100 and this is the tippy top, 100, 120, 140, 160, 180, 200, and then the top is 214. So answering the question above, which side of the mountain is more steep, the west or the east side? Where your contour lines are close together, you have a very steep side of the mountain. Where your contours are far apart from one another, you have a gradual slope. So it's not steep. Okay, I hope that's helpful for your assessment.